Hello students, let us continue the session on triangles. In the previous session we have discussed about Thales theorem or basic proportionality theorem. Let us solve few questions related to the basic proportionality theorem. The first question is, if in triangle XYZ, P and Q are 2 points on XY and XZ respectively, such that XP is equal to 4 cm, PY is equal to 3 cm, XQ equal to 6 cm, and QZ equal to 4.5 cm, and angle XPQ equal to 40 degree, then find angle XYZ. In this triangle, XYZ, P and Q, they are the points on XY and XZ. It is given that XP from here to here, it's 4 cm, PY is 3 cm, QZ is 4.5 cm, XQ is 6 cm, angle XPQ is 40 degree. We need to find the angle XYZ. How do we solve this? Look at the ratio of XP by PY. XP by PY is 4 by 3. And observe XQ by QZ, 6 by 4.5, it is divisible by 1.5. 1.5 3 times is 4.5, 1.5 4 times is 6. Here the ratio XP by PY will be equal to XQ by QZ. This implies PQ is parallel to YZ. If the ratio of the sides are proportional, then the lines PQ will be parallel to YZ. Therefore, angle XYZ is equal to angle XPQ, which is equal to 40 degree. The second question is, in the figure, XP is equal to 6 cm, YP is equal to 2 cm, XQ is equal to 7.5 cm. We need to find QZ. This is to be found, it's not given. XP is 6 cm, it's a different figure, 6 cm. XQ is 7.5 cm. This angle is not given. YP is 2 cm. From basic proportionality theorem, we have XP by PY equal to XQ by QZ. This implies XP is 6 cm divided by PY is 2 cm, which is equal to XQ 7.5 divided by QZ. So QZ will be equal to 7.5 into 2 divided by 6. On simplification, we get QZ value as 2.5 cm. Third question, at a certain time of a day, A man 6 feet tall casts his shadow 8 feet long. Find the length of the shadow cast by a building 45 feet high at the same time. This is the corresponding figure. XY represents the man standing, which is 6 feet, and the shadow cast will be YZ. Here in the figure I have considered X to be the length of the shadow of the building. Let me mention that. Let the length of the shadow of the building be X. As the source of light is the sun, XZ will be parallel to PQ. Here, when XZ is parallel to PQ, the corresponding angles will be equal. This angle and this angle are corresponding angle, and this angle and this angle are corresponding. It's a common angle. So by AAA criteria, I can say that triangle XYZ is similar to the triangle PYQ. When the triangles are similar, the ratio of the sides will be equal. So I can consider XY upon PY equal to YQ upon YZ. This implies this is YZ upon YQ, 6 by 45 equal to 8 by X. So we can find the value of X. X turns out to be 60 feet. So the shadow of the building is 60 feet. Now let us learn proof for converse of basic proportionality theorem or converse of Thales theorem. The statement of the theorem is the line dividing two sides of a triangle proportionally is parallel to the third side. The line dividing two sides of a triangle proportionally is parallel to the third side. We need to prove that PQ is parallel to YZ. What is given here? The given is the sides are divided in proportion, that is XP upon PY is equal to XQ upon QZ. We need to prove that PQ is parallel to YZ. Proof: XP by PY is equal to XQ by QZ. This is given. Now if I take the reciprocal, I'll get Py upon Xp equal to Qz upon Xq. Now let us add 1 on both the sides. If you add 1 on both the sides, what do we get? We get Py plus Xp upon Xp equal to Qz plus Xq upon Xq. This implies Xy upon Xp is equal to Xz upon Xq. Now in triangle XYZ and triangle XPQ, we have Xy by Xp equal to Xz by Xq. This is from 1. And angle YXQ angle YXZ equal to angle PXQ. This is a common angle. Now the sides are proportional and angles are equal. By SAS similarity, we can say that the triangles are similar. Therefore, triangle XYZ is similar to triangle XPQ. If XYZ and XPQ are similar, the angles are equal. These two angles will become equal. So I'll write it as angle XYZ will become equal to angle XPQ, which implies YZ is parallel to PQ because corresponding angles are equal. Whenever pair of corresponding angles are equal, the sides are parallel. We have learned it in class 7th. Now let us solve few questions based on the basic proportionality theorem and converse of basic proportionality theorem. Here we have a question. ABCD is a trapezium with AB parallel to DC. E and F are the points on non-parallel sides AD and BC respectively, such that EF is parallel to AB. EF is parallel to AB. Show that AE by ED is equal to BF by FC. Here, to prove this, let us make a small construction. Let me join A to C. Let the point of intersection where it cuts EF, we name it as G. So let me mention that. Let us join AC to intersect EF at G. They have given that AB is parallel to DC and EF is parallel to AB. So when two lines are parallel to each other, we can get EF parallel to DC. Lines which are parallel to the same line are parallel to one another. In triangle ADC, we have EG parallel to DC. This implies AE upon ED will be equal to AG upon GC. This is by basic proportionality theorem. Similarly, we have in triangle CAB, CG upon AG equal to CF upon BF. That is, when I take the reciprocal, AG upon CG will be equal to BF upon FC. Let me name this one as 1 and this one as 2. From 1 and 2, we have AE upon ED equal to BF upon FC. Hence, we have proved it. Let us solve one more question. In the figure 6.16, PS upon SQ is equal to PT upon TR and angle PST is equal to angle PRQ. Prove that PQR is an isosceles triangle. They have given that PS upon SQ is equal to PT upon TR. This implies ST will be parallel to QR. The reason is from converse of basic proportionality theorem. When the lines are parallel to each other, we can get the corresponding angles. Angle PST will become equal to angle PQR. These two angles will be corresponding angles. But angle PST, they have given it as equal to angle PRQ. On comparison, PST is there in the left hand side, they are equal. The right hand side must be equal. Angle PQR will become equal to angle PRQ. Whenever the two angles of a triangle are equal to each other, the sides opposite equal angles are equal, so PQ will become equal to PR. The reason is sides opposite to equal angles. Therefore, PQR is an isosceles triangle. Now let us begin with the exercise questions. Exercise 6.2. In the figure 6.17, first one and second one, we have DE parallel to BC. Find EC in the first one and AD in the second one. Let me solve the first one here. Let EC be x centimeter and they have given that DE is parallel to BC. This implies the ratio AD upon DB will be equal to AC upon EC. This is from basic proportionality theorem or Thales theorem. Therefore, the ratio 1.5 upon 3 will be equal to 1 upon x. The value of x will be 2 centimeter. Let's solve the second one. Let me consider the length of AD to be x centimeter now. Since DE is parallel to BC, we have the ratio AD upon DB is equal to AC upon EC from Thales theorem. You can mention it as a basic proportionality theorem, no issues. AD upon DB is x upon 7.2. This is equal to 1.8 upon 5.4. This implies the value of x is 1.8 into 7.2 divided by 5.4. On simplification, we get it as 2.5 4 centimeter. So the length of AD is 2.4 centimeter and the length of EC is 2 centimeter. That's all for today's session. Let us continue the exercise 6.2 questions in the next session. Thank you.